My name is Simon Tennant, and just around Easter of this year, I got a call from this gentleman here, Alan Not Craig. He is in South Africa, and his request to me went something along the lines of, we've got about 500,000 users on our free Wi-Fi product in South Africa. So he runs a company that gives out free Wi-Fi for people who live in the townships in South Africa. So these are people who pretty much have nothing. Maybe they have a mobile phone, but they get free Wi-Fi from his company. In fact, the interesting thing is you can see up here the different Wi-Fi access points. Louder? Okay. Let me try this. I don't think it can go any louder, I'm afraid. It's apparently on. Is this okay? Okay. All right. So I'll try and go louder. Anyway, the point is that these guys said, we need a mobile social network, and we have about 10 days to build this thing. Can you help us? And normally building a mobile app and getting everything working in 10 days is going to be kind of tricky, especially when you're talking about user-to-user interaction. So we thought this sounds like a great challenge. We jumped on a plane and we went off to South Africa. And we did this project because we build an open source messaging stack. So what that means is that basically we get users talking to each other. So if you're building a mobile app and you want your users to connect and share and communicate and do Facebook-like things without pushing everything off to Facebook, then you would probably use our open source stack. And it's basically a bunch of different components that do a bunch of different things that you need to do messaging. So that means you've got sort of things like a way to share media. You've got a way for your users to chat. You have the sort of standard things like push notification that then talks to Google and does all of that stuff. So you use this product to build apps, essentially. You can basically drop it in, and it's an open source stack. And it's all Apache 2 licensed. So essentially you just do whatever you want to do. So today I want to talk to you about some of the design decisions around this. So why we decided to use a certain messaging protocol, how we work with different standards bodies, and then to talk you through some of the problems we had, and to talk you through some of the code implementation that we did. And then to talk about microservices. And it's not going to be pretty, but we'll get there in the end. So I have this opinion that messaging is like the new operating system. And when I say messaging, I'm talking about user-to-user chat, not sort of 0MQ messaging or anything like that. And essentially, this is the new operating system. It used to be that if you were building, if you're building an application, you'd say your application expands until it can read email. I think the new thing is that your application essentially expands until you've got a level of users talking to users inside of this. So this is like the Airbnb app where hosts are talking to guests. There's other apps, for example, one we worked on where electricians talk to plumbers. So I really think that there has to be a good open source way to do this, to just add all of these components into your application. And that's what our team does. And we try to do it a little bit differently. So instead of, we're kind of conservative. That means we only have little bits of Node, and we only have little bits of, in fact, we don't even have any Go in our software stack. So we sort of tend to be a little bit on the pragmatic side and a little bit boring because we know that this stuff really, really has to work. And what I also mean about this pragmatism is that we work with some of the standards bodies. So when you work closely with standards bodies, these people are incredibly idealistic. And we think that particularly in messaging, there's what users want to do, and then there's what standards people think you should do. So all of our work tends to be around the pragmatic side of things. So we we work on stuff, and then we take it and try to standardize it so that others can implement it. So yeah, the talk today, I'll talk a little bit more about XMPP, and then we'll go into some of the problems. So we chose XMPP as a messaging protocol. Who knows what XMPP is? Okay, about 10 people. Okay, we're off to a good start here. Well, it's actually, you probably all know what it is because you're using WhatsApp, which is sort of like a hacked up version of XMPP. If you've got an Android phone, it's using XMPP to handle push notifications. Facebook's chat on their web page, somewhere deep in their stack, is powered by XMPP. So it's everywhere, but it's sort of not the super sexy protocol. It kind of gets pushed away. And I think some of that's because it's, at its roots, it's about a 15-year-old protocol, which on the one hand means that it's quite mature. On the other hand, it means it's not getting huge publicity. But yeah, we chose XMPP over a bunch of other things because we kind of like open stuff. And we think that open generally wins out. So just for contrast, we think that by building an open messaging stack, we can actually, play against Facebook at their own game, but without going directly to them. We think that we can eventually subvert Facebook, but not by creating yet another Facebook. We give developers the tools to chip away little bits of Facebook. So yeah, XMPP is interesting because it's federated. So what that means is that sort of like email. If you're a Gmail user, you can talk to a Hotmail user, you can talk to or send email to a Hotmail user. XMPP is a little bit similar in that, Romeo can send a message to Romeo's server, which can then eventually get over to Juliet's server and then to Juliet. So it's sort of this system which, instead of having a central owner, anybody can run their own XMPP server. And for me, that's quite exciting because I think there's so many silos out there. There's, Skype, which only works with Skype. There's WhatsApp, which only works with WhatsApp. This is kind of cool because you can run your own XMPP server and you plug into a network of millions of other potential users. So there's this idea that you can send a message to a user and you can then even send it to their different devices. So maybe the user has a mobile phone that's connected, maybe they have a web app, and you can actually specifically direct the user by adding this optional resource parameter on the end of the message. So you can see this starts to become quite useful when you're building a mobile application because you can have multiple different clients online, you can send different messages to them. And yeah, the messages are, as I warned you, they're XML-based. So some of you are probably recoiling in fear because, the world can only live on JSON, but we've got a solution for that, and I'll come to it in a minute. So yeah, it's XML-based, and this is quite nice because the X part is the extensibility part in that you can add more stuff. So maybe you want to add optional parameters. For example, this, the threading bit. So this is an extra parameter that's added to a message. And so you can really sort of customize things out to your particular application need. Yeah, and as I mentioned, it's federated. So one server will talk to other servers. So if I'm talking to your server, my server holds open a connection to your server for about 5 minutes, and if it sees no more traffic going between us, it'll drop the connection. So, and then the other thing that we're finding is quite useful for this is that when you're talking to banks or to pharma or healthcare, these organizations start to care a little bit more about their stuff being in their own data center versus, it's just in the cloud. So one of the big sort of pluses of this is that you can self-host it, you can run it on your own infrastructure, and then decide what sort of messages you want to pass between different services. In fact, there's even a specification. One of the organizations that we talk to and work quite closely with is they have this idea of tag messages. So a message is either secret or top secret. And depending on the clearance levels, it means it can go outside of the organization, or it should stay inside the organization. So yeah, this federation stuff starts getting super interesting as well, because not only are your users federated, but you can have processes that are federated. So you could run a service that needs to talk to another service, and it's sort of just network transparent. You don't have to think about it. You just know that your messages will get there. And an example of that message could be like a location service. So imagine you have your mobile phone and it's recording like what cell towers it sees in the area. It can push those cell tower beacons off and get a location back. So that starts becoming quite useful. And this is actually something we built where we would look to try and look at the different cell towers in the area, look at the Wi-Fi in the area, and let you bookmark a place. Sort of like Foursquare before Foursquare. So yeah, putting this all together, we've got a whole bunch of components, and these are all connected through XMPP, but we know that the rest of the world doesn't want to see XMPP, they don't want to see XML. So we've got this sort of layer up here that makes sure that all the XMPP stuff stays down here, and the rest of the world just gets a nice REST API, and you can use WebSockets or REST to do all the things you'd expect to do, like post a message, post a file, stuff like that. So as I mentioned, we try to standardize everything, and this is like a 2-minute intro to how the standardization process works. So imagine you've invented something you think is super cool and you want other people to use it. You can essentially just write a standard, and it goes through a standards organization. So that's, in this case, it's the XMPP Standards Foundation, and they try to standardize, basically saying, perhaps there's like 5 or 6 people who are interested in doing location sharing, for example. Well, let's try and find a general way that we can describe this so that people can write servers for it, or people can write clients or libraries for it. So in our case, we were working on this location sharing thing, and we thought, it would be nice to be able to get nearby places back and sort of to describe what your phone can see and then get a location back. So this process works. You sort of write up a specification. It gets argued over, and you can see these different specifications, like they're called ZEPs. So, when you start the process, you'll get assigned a ZEP number. You have lots of arguments backwards and forwards about what's really the best way to do it. And really the best way to do it is the way that you're doing it. So it's sort of like a do-ocracy. Whoever gets stuff done actually writes the standard. And then you get to a place like this, which you sort of sit around, you do a lot of chin wagging. This is the XMPP Summit. It happens once a year. And you kind of go through the different standards and you say, this is why we're doing it this way. And somebody else says, well, have you considered this? And finally, you get to this point where you have a standard which sort of describes the way to do location stuff. So this is all XMPP. Now let's talk about actual real mobile stuff. So the nice thing about, or the thing that's super important for any kind of communication is going to be push notifications. Because your phone, in the old world, or even the desktop world, your phone sits there, it's got a long-lived connection to all the different services that it cares about, and that doesn't matter. Your battery life doesn't matter. But try to keep a long-lived TCP connection open on your little phone, and it's, your social life is going to end about lunchtime when your battery's dead. So what the phone manufacturers have done is obviously push notifications. We all get them, we all depend on them. They're kind of important if you want to get users coming back to your service. So in an ideal world, you'd have your user on a browser and they connect to another user on a phone and they'd send messages backwards and forwards. But we're not in such an ideal world. We have to deal with network carriers that have massive NAT pools that sort of chop connections, or you think you have a connection and it's not really there. So your user comes back online, and they also need to pick up their messages from the backend service. So this is probably how some services would be implemented. But this is really going to kill you because your phone's now having to keep like a long-lived session open. And so we don't want that. We want a push notification server. And essentially, if you're using an iPhone, you're stuck with Apple's push notification service. If you're using Google's, you're stuck with Google's. So now what your phone is doing, instead of keeping a TTP session open for every single application that you're running, it's just keeping one open. And what your application is then doing is firing up a push notification to the service, and then that sends like, hey, there's a new or new content, or there's a new like, or there's something new for you. Come and get it, and then your phone picks it up. But this does kind of mean you need to work with how Google expects you to do push notifications, or how Apple expects you to do push notifications. And that means there's size limits on how much data you can send through. You don't use push notifications for things like, here's a picture of my new kitten. You do want to use it for, hey, there's something new, come and pick it up. So this is called the push-to-pull model. Hey, here's a push notification, like connect it back to your REST API and pull the data you need. So it sort of goes something like this. Oh. Sorry. That's a push notification. So, let's hope no more come back. Yeah. And so actually what's happening is if it's a small message, your phone will pick it up and get it. If it's a larger message, it's really like, come and get this. And how that fits in with what we've done is, you have your chat server or your channel server. I should just explain, the channel server is like your activity feed. So whenever somebody's posting something into your activity feed, or you're getting a chat message, everything gets pushed to the push notification service. So the way we sort of designed this is we said, every time that something's happening, just mirror it across to the service. We don't care what it is, but this push notification service can then work out, is this something that the user cares about? Should I fire off a message up to Google or Apple or whatnot? And so it's a way to kind of set your preferences for it. Anyway, you get this message, fire it up to Google and Apple. That sends a push notification, and it's a simple REST pull and get the latest likes or the latest messages or whatever. But another problem we had, when you're firing a lot of push notifications, you want the user to sort of feel something buzzing in their pocket, turn on their phone, and then you want the content immediately, straight away, visible to them. And so this is something that WhatsApp was actually very successful about. They did a really, really good tech talk. If you look for WhatsApp and time to glass, their whole driving factor was that you should have a 1 second time to glass. And what that means is you pull it out, turn on your thing, and you've got the message there within a second. And that really sort of helps the user fluidity. So if you start doing that, you really want all the data to just be a one-shot, like give me everything I need to display and for it all to come down at once. You don't want to be in a sort of situation like this where you say, give me new posts, and your REST API goes away and sends you back, here's a post, and these are the two authors. Because now you've got to go back and say, well, actually, I need to know who these authors are, and you're firing off another request. So your 1 second time to glass is dead at this point. So I think you all know the solution to that. Just include as much stuff in the server response, so you're getting one REST call, one answer back, and then you've got your 1 second time to glass for getting a push notification, pulling your phone out, and you've got the data there. So then the next problem is the fact that we kind of want messages to be secure. So security comes with an overhead. TCP comes with an overhead. When you're setting up a TCP socket, it takes a long time, particularly in a mobile network. Instead of your DSL connection, probably a latency of 30 milliseconds, so you've got 30 milliseconds to your server, a little bit of time on the server, data coming back. You've actually, you're talking more like 300 milliseconds from your phone to the radio tower to the network and getting the data back. So yeah, this is something that when you're building an application, you really want to be thinking about, particularly on the mobile network. So just spinning up a normal TCP session is going to take time. So you're doing a DNS query. So if you can cut down the number of DNS queries you need to do, probably by a very high DNS timeout, that'll definitely help things. You've got a TCP handshake going on, data coming in from the first request, but then you probably also want HTTPS, so it's 2 more round trips. And so I don't have like a silver bullet solution for this. This is just the realities of the speed of light. It takes time to get data backwards and forwards. So the fewer round trips you can do is important. So particularly with sorting out certificates. So if you've got like a lot of, if you can optimize your SSL configuration so that you're sending down all of the certificates in one shot, your browser's not having to go off to the server and get intermediary certificates, then that'll definitely help. But if anybody wants to talk about this later, we've done tons of optimization to try and get this fast and using low data on mobiles. I'm happy to talk about that afterwards. So yeah, anyway, now we're on to the part where we actually build the application. So 10 days to build an application is kind of short, particularly if you wanted to do a whole lot of things. Thankfully, we've got all these building blocks. They're all open source components. You can just pull them out and glue them together. So let me talk you through some of the things. So the first part we had is doing a DNS discovery. You need to know where your API endpoint is. So we abstracted this a little bit. And yes, this does increase the time to glass. But we thought it was important because we thought that if I build a mobile app, I should be able to run it on your server and your server by just changing a username. So it's kind of nice to know where the API is. And this is just a very simple DNS text record. And it's essentially saying, the server is buddycloud.example.com. You should use HTTPS. This is a port, and this is the API path to start doing all your requests at. So then we sort of said, OK, normal mobile developers don't want to know anything about XMPP or XML. So we give them a REST API. But now you've got a strange world because HTTP is sort of, it's a stateless protocol. You've got your cookie kind of keeping state. And you've got XMPP, which is this like long-lived connection. So we built a nice little API that essentially says, we're going to keep our state in the API, and that's just going to hold open the XMPP bits. So you can, and if the user doesn't do anything for 5 minutes, then just drop the XMPP connection at the back end. Yeah, and then the next part was we had to do sign up. So we didn't want to, most times when people want a mobile app, they probably already have users. So building a system where you're saying, oh, here's yet another user database, yet another password. We said this really wasn't a starter for us. So essentially, all of our components use external auth, which is just fires off a connection to a remote server and says, does this user exist with this username and password? Yes or no, and then they come on. So those services where you sort of like download and install the app, and then you're not quite sure what to do or who to follow. And I think this is something that modern services are better at, but we're not quite there yet. So yeah, skip over that. Yeah, the onboarding stuff is is kind of interesting. You really want the user to be active from day one. So if you look at something like Instagram, you sign up on that, and immediately it's going through your address book, finding people you might know. So we built an onboarding component that will auto-subscribe you to a few what we call channels. And it'll also try and like recommend active content for you to follow. But then also with onboarding, you kind of want to like recommend stuff for the user. So we've got a little algorithm that sits in the back end that's sort of tries to work out who's posting interesting content, and you can weight that. So you can say, you know, these guys are always posting interesting stuff. Maybe not today, but these are people you should follow. And then the other part is you want users to discover content. And I think the best service that does this is Amazon. When you're shopping on Amazon and you find a book, it recommends other books that you like or might like. And that's essentially just using something called a taste engine. There's an open source Apache project called the Apache Mahut project. And as long as you can feed in lots of key values to that, you can get some quite nice answers out. And it can be of the form like that. You know, based on what you follow, you might like this. Or because you're following this, you might like this. And then we added on another little thing, which we think is kind of cool. If you want to build like an app for a conference like this, you can just tag channels with a latitude and longitude, and it'll show you nearby stuff. And we think that's quite a nice way for users to discover. Yeah, so content discovery is obviously important. But then you want your users to actually post stuff and start getting active. And this kind of comes down to the app design. You know, you install the app, you kind of want to prompt the user to do something straight away. And yeah, so we've got the idea that you can post a topic and a topic, and then you can have your friends commenting on stuff. And finally, no app is complete without picture sharing. Very, very important. So putting this all together, as you've seen already, we've got this diagram that looks something like this, where you've got a bunch of different components that you can add your new components, things like a friend finder that will recommend people you might know, stuff to chat, stuff to recommend content. And really with our designers, we've tried to take the Unix philosophy. We say like one service should do one thing, should do it really well, but it should be interconnected and should work with other services. So yeah, as I mentioned earlier, we have this separation between the two worlds. So we've got the JSON stuff, you're getting JSON objects back, and we've got the nice the world that's slightly more extensible, if my presentation clicker works. Let's just try that, yeah. Okay, sorry, minor technical difficulty here. Okay, so yeah, this is the project we built. It's called WiFiChat. We chatted with the organizers and said, you know, we're coming down here to build this chat application for your users. We want to make it open source. So if you happen to need an open source little social network mobile app and you want to hack on it, fork it, whatever, it's there. This is basically in one of the townships using the application. And the interesting part about going to South Africa is that you're sort of hacking away. Network connection's great, but you keep losing power. So it's a good way to work out who's got the newest MacBook by whose battery dies soonest or last. So yeah, we spent a lot of late nights hacking on this project, but we were able to get it done in just 10 days of working. So let me show you some of the code. This should be fairly obvious to most of you. Yes, you see XMPP in there, but that's just really the function call. The rest of it is pure JavaScript, and and what you're doing here is just authenticating. Once you've authenticated, you're going to want to actually say, I'm online. And sending your presence is the way of saying, like, I'm online, now start sending me events. Start sending me new messages as they come in. And so going online would then start sending you the activity feed of what different users have done. So as I mentioned earlier, we've got these things called channels. So yeah, we have a channel of topics. So I guess the equivalent is like a Facebook group or a Twitter feed for a company or something like that. And it's then possible to set up a channel. So to create a new channel, you're just giving it a title, giving it an access model. So you could have a private channel that only certain people can be a member of. And that's just saying, look, this is either whitelist or blacklist model. And whether somebody joining it can actually post to it. So if you're running Lady Gaga's channel, having your 10 million fans all able to post is probably going to be a nightmare. But having them coming on as just readers is going to be a slightly more sensible option. Yeah, so what are we doing here? Yeah, little example of chat messages coming through. What I haven't mentioned is that everything on the back end is publish subscribe. So we've got this observer model. And that basically means, well, it's essentially like a Twitter feed. So you've got somebody who can post and then multiple people observing what gets posted. And then actually getting content, something that's important on a mobile. Imagine you haven't used an app for a month and then you pull it out your pocket and it starts sending you everything since the last month. That's going to be a kind of sucky experience. So you really want to be able to say, just send me the newest data, but then if I go back, you want to like chunk in new data. And so that's what RSM is. We should see RSM somewhere up here. Yeah, result set management. That's just saying send me 6 items at a time. Yeah, this is all available. All the code is on GitHub. But something we ran into one problem. You know, as you saw the stack, it's kind of complicated. There's a lot of little components, and every time you start running multiple components, you run into configuration complexity. Now, some of you will probably say, but microservices. And so I think we should actually talk about, you know, why microservices, yes or no. I'm sure there's some more talks about that. But for me, it's important that when we deploy stuff, it can always be exactly the same stuff that I'm working on my laptop is going into production. Maybe a different host name, maybe a different database username, password. But that's kind of important. So the old way of doing this was, you know, you would be, skip through this. Yeah, you'd be basically SSHing into a box and untarring a file. And I think the less we talk about this, the better. So some of you are probably thinking, but Docker. So here's my quick take on Docker. We went down the Docker route about 2 years ago and dealt with it for about a year. And we kept hitting it up against it. And yeah, it was an interesting experience. My quick summary about using Docker is it's really a nice way to do it. But if you are going to do that way and you care about security and you care about your container not changing from underneath you, think about Linux containers. And this is really the way we've gone now. So we've kind of realized that containers are a good way to do this stuff. You kind of want to deploy your backend using containers. But yeah, the Docker project we found just to be too unstable. But really the biggest takeaway was that you need orchestration. Docker has the notion of orchestration. It says, you know, pull in this file, change this configuration option here. But it's kind of, it's weak orchestration. You can't really do very much. And when you want to make big changes, it takes a long time. And that kind of sucks if you're deploying at a customer and you need to quickly make alterations and spin up your new environment. So what we ended up doing was, this is quite a good little way to think about microservices. And so happy to talk about this more afterwards because I know it's a bit of a contentious subject. But yeah, the idea that we came up with was we need an orchestrated VM. We don't care so much about containers. We know that stuff's going to run in a container eventually. But you want to orchestrate from your virtual machine into a staging environment, into a production environment. And for that, you need something like Puppet. We ended up going with SaltStack, but Ansible or anything else. And that's just the way you should be doing things now. Yeah, if you want to play with it. Oh, quick. This is basically what we're doing now to run different services. So this is an example of using SaltStack, where we've got some dependencies. We pull down the actual binaries. We have file hash checking, which gives you a level of security. And then, yeah, we set up the database. We set up some configuration files. In fact, just ignore that, please. Yeah. Yeah, if you want to play with it, everything is on GitHub. We're on Twitter. Follow us or come grab me during the talk. Happy to talk more about messaging. All right. Thanks, everyone.